Hi everyone, this is Srinivas, your maths faculty. Welcome to Akshara IIT Foundation. Let us go to the today's class. Today we are going to discuss about rational numbers. Okay? So rational numbers are nothing but the numbers which can be written in the form of P by Q. Written in the form of P by Q, where P and Q belongs to integers and Q does not equals to 0. What are the numbers we can express in the form of P by Q? Are called rational numbers, where P and Q must be integers and Q does not equals to 0. Okay, such type of numbers are called rational numbers. So nothing but all natural numbers are whole numbers, right? Natural numbers are nothing but counting numbers. So 1, 2, 3, 4 and so on. All counting numbers are the part of whole numbers. And all the whole numbers are in integers. And all the integers are in rational numbers. That means every number which is in set of natural numbers and whole numbers or integers, all can be rational numbers, because all the numbers we can express in P by Q form. Okay, that means, sir, 5 is a natural number. How can we express 5 in P by Q form? 5 is nothing but 5 by 1. Or we can write 5 as 10 by 2 also. 2 table in 10 5 times, right? So that 5 we can express in the form of P by Q, 10 by 2 or 5 by 1. 1 table 5 times. Okay? So that means every natural number we can express in P by Q form, as well as whole numbers, integer, every number we can express in P by Q form. Okay? So, and I am representing this P by Q form with the symbol Q. That means the rational numbers are represented with the symbol Q, where the set of numbers are in the form of P by Q, and P comma Q belongs to integers. Q does not equals 0. Here we are representing with Q means it is having another name, that is quotient numbers. Quotient numbers. Okay. We can represent with the letter R now. Why we are using the letter Q? Because with the R we are representing one more set of numbers that are nothing but real numbers. Okay. Right. So rational numbers are nothing but they are in the form of P by Q, and P and Q are integers. Q not equal to 0. If Q becomes 0, we cannot define that value. We cannot define that value. For example, let us take 7 by 0. It is also in the form of P by Q. P means 7 is integer, 0 also integer, but it does not exist. See, 0 table 7 how many times will come? 0 1s are 0, 0 2s are 0. 0 with any number is 0. 0 into 1 lakh also 0 itself. That means 7 by 0 is not defined. That's why the condition we have to write that the denominator Q does not equals to 0. Okay, na? Right. Now let us go to the positive rational numbers and negative rational numbers. Positive rational numbers means while you are observing the rational numbers, both numerator and denominator having the same sign. Both numerator and denominator having the same sign. Such type of rational numbers are called positive rational numbers. Like 5 by 7, minus 3 by minus 5. Minus 3 by minus 5 also a positive rational number. Both numerator and denominator having same sign, they are called positive rational numbers. Okay, na? This is an example for this. And what is negative rational numbers, or what are negative rational numbers? Yeah, according to the definition of positive rational numbers, both numerator and denominator having same sign. Here, numerator and denominator having opposite sign. Such type of rational numbers are called negative rational numbers. So minus 2 by 3. That means numerator is negative integer, denominator is positive integers. So both are opposite sign. So this is considering as negative rational numbers. Okay. Minus 6 by minus 7. Is it negative or positive rational number? Both are having the same sign. Same sign means it is a positive rational number. Now see, 6 and minus 7. Both are opposite sign. Now it is considering as negative rational number. Okay, now? Right. So we discussed about the rational number definition, what are rational numbers, and positive rational numbers, negative rational numbers, and let us see standard form of a rational numbers. What is that? Standard form of a rational number. That means if you take any rational number, that rational number must be in simplest form, as well as the denominator of a rational number always positive. The denominator of a rational number must be always positive. Such type of rational numbers are called, such type of rational numbers, we can say that they are in standard form. Okay, right. So let us see the example of a rational number. For example, I am taking a number like 256 by 1000. Okay, so both are having a common terms here, common factors we have, because both are, we can cancel in 2 table, 4 table also. Am I right? So let us simplify this. So I am cancelling 4 table, 4 6 are 24 and 4 4s are 16. That means 4 table into 56, 64 times 4 25 is 100, 250. Again both are cancelled in 2 table. This is 32 and this is 125. Now check any other cancellation here. 32 by 125. No. So there is no common factor between 32 and 125. So 32 by 125 is standard form of 256 by 1000. Okay, na? That means whenever you have seen the rational numbers like this form, we need to convert it into its simplest form. Okay, and you see here denominator does not have any negative symbol, so it is in standard form. Okay, let us take one more example here. Minus 84, okay, 84 by minus 126. Again both are having a common factor 2, so let me cancel in 2 table 42 here 63. 42, 2 table in 84 42 times, 2 table in 126 63 times. Okay, now let us cancel both of them in 7 table, 7 6 are and 7 9s are. Again both will cancel in 3 table, 3 2s, 3 3s. So that is 2 by 3, but we are having the negative symbol here. That negative symbol is applied to all the denominators. So this is 2 by minus 3, even that is not in standard form because the denominator is negative integer, so we need to make them into positive. That means minus 2 by 3. Okay, same this minus symbol I kept to numerator, that's enough. So this is the standard form of a rational number. First it must be in simplest form, then after we need to check the denominator having the negative symbol or positive symbol. If the denominator is in positive symbol, negative symbol, we need to convert it into positive symbol by multiplying with minus. So we discussed about the rational numbers, positive rational numbers, negative rational numbers. Now let us see the density property of a rational number. So density property. So density property means if you take any two numbers, between the two numbers we can write uncountable number of rational numbers, or we can insert uncountable number of rational numbers. Such type of property is called density property. Okay, na? That means if you are taking any two numbers A and B, any two rational numbers or any two integers or any two whole numbers, what not, between them we can insert, that means between them there are uncountable number of rationals. Uncountable number of rational numbers we can insert. This property is called density property. Now for example, A and B are two rational numbers, then between numbers is b minus a by n plus 1. This is the number of rational numbers we can insert between them, right? 10, 20, what not. We can take infinite number of rational numbers between them. Okay, na? Here a value is less than b, then only we can apply the condition like this. Here n is nothing but number of integers between them. We want 9 numbers of integers. We want 9 number of integers between them. So we should write in the place of 9. In the place of n we should write 9. So 9 plus 1, 10. So let us take b value is 5 and a value is 4. So this is 5 minus 4, that is equal to 1 by 10. 1 by 10 is the number which is lies between. This d is nothing but difference. Okay, na? That means difference between any two numbers. Like this we have 1 by 10, right? 1 by 10 is nothing but 0.1. So the rational numbers between a and b we can write a plus d, a plus 2d, a plus 3d and so on like b. So this is the value of d. In case a value is 4, b value is 5, we can find between them 10 rational numbers or 9 rational numbers. So this is 0.5, right? What is the next immediately number? A plus d. A plus d means 4 plus 0.1, 4.1. Next 4.2, 4.3, 4.4 like that. If you want to find 100 rational numbers between them, n value should take 100. 100 plus 1, 101. So again that decimal number we can add like this. Okay, no? Here d is the difference between consecutive rational numbers. So what is density property? We can write infinite number of rational numbers between any two numbers. Okay, now check. So let us go to the next one. Let us see one example based on this. To find 99 rationals. Find 99 rational numbers between 20 and 21. 20 and 21, two consecutive whole numbers or two consecutive integers. So in between we need to find 99 rational numbers. Rationals between 20 and 21. Okay, na? So let us see. So what is the formula actually? The first rational number, the smaller one is 20. Next a plus d, a plus 2d, a plus 3d and so on like this. Last one is b. That means first one is a, second one is b. In between we need to keep 99 rational numbers. Okay, na? A value we know, b value we know. To find d value we are having the formula b minus a by n plus 1. B minus a by n plus 1. So let us substitute. B value is 21 minus a value is 20. N is nothing but number of rational numbers between them. There are 99. So 99 plus 1 is 100 denominator and 21 minus 20 is 1. 1 by 100 is nothing but 0.01. 1 by 100 means 0.01. So from this, first number is 20 and last number is 21. Between them we need to write 100 numbers. That means 99 numbers. So next one, 20 plus 0.01 is nothing but 20.01, 20.02, 20.03 and so on like 20.99, 99. Then it will be 21 afterward. Okay, na? Like this we can write 99 rational numbers between two numbers. Okay, na? Check. Okay. So let us discuss about the properties of a rational number. So let us see the properties. Properties means we know that closure property, commutative. We are checking this properties for every set of numbers. It can be natural numbers, whole numbers, integers and rational even. Okay, na? Yeah, let us. So closure, commutative, associative, and distributive. Main these four. Okay, na? So let us see the closure property. What is closure property? Closure property is nothing but when you take any two rational numbers, their sum also a rational number, or their product also must be a rational number. Like that, if a set of numbers are satisfying these conditions, we can say that the all numbers are in a closure property. Okay, following the closure property. What now? So, for example, A and B, any two rational numbers, A and B, any two rational numbers, that means A comma B belongs to Q, then A plus B also in set of rational numbers. Same way A minus B also in set of rational numbers. A into B also set of rational numbers. A divided by B also a rational number. But actually for rational numbers addition, subtraction, multiplication are satisfying closure property but not a division. Okay, na? So this is closure property. We can easily identify that. For example, 2 by 5 plus 7 by 5. This is first rational number. 7 by 5 is a second rational number. Add both of them. That means among the four arithmetical operations, I am applying the first arithmetical operation plus symbol. Then it will be 9 by 5. 9 by 5 also a rational number or not? Yes, because it is in the form of P by Q. So first one rational number I have taken, second rational number I have taken. I am adding both of them. I added both of them, then I'll get the answer. That is also in the set of rational numbers. So closure property satisfies. Okay. Next, what is commutative property? Commutative property for every A comma B belongs to rational numbers. That means if you take any two rational numbers, A plus B value as well as B plus A value must be equal. A plus B and B plus C. Both are equal. Such type of property is called commutative property. Okay, now even the A plus B and B plus C, if we add in any order, it doesn't matter. The sum of the two numbers will be obviously same. Okay. Next, associative property. What is associative property? If you take any three rational numbers A, B, C, or any three rational numbers, we should write that A plus B plus C equals to A plus B plus C. Okay, no? So this is the property of associative property. Let us see example for here. Commutative. I am taking 5 by 7 plus 3 by 7. Like terms only I have taken. Add both of them. What is the answer? Same denominator 7. We can directly add the numerators. 5 plus 3, 8. 8 by 7. Now I am adding 3 by 7 plus 5 by 7. I have changed the order. Denominator is same. 3 plus 5. 3 plus 5, 8. Both are equal or not? Yes. Commutative property satisfying the addition. Arithmetical operation. One of the arithmetical operation addition. But it is not satisfies the subtraction. Okay, na? Yeah. Such type of property is called commutative property. Same way here, three terms A, B, C, three rational numbers you have to take in. When A plus B plus C equals to A plus B plus C, then we can say that that associative property satisfies the rational numbers under addition. Okay. Next, last distributive. Distributive property also something like this only. So what is distributive property? A into B plus C. For every A comma B comma C belongs to rational numbers, A into B plus C is equals to A into B plus A into C. A into B plus A into C. That means the number which is outside the bracket, this number is equally distributed to A as well as A. That means which are in the bracket. A into B here, A into C. Okay. Such type of property is called distributive property. Please note it.